So this is the parallel flow heat exchanger, also often referred to as a double pipe heat exchanger. It's a common solution for transferring heat between two fluids, a hot and a cold fluid. It transfers heat from the fluid in the interior pipe through the pipe wall to the fluid in the exterior pipe. We have the actual concentric pipe heat exchanger here, or double pipe heat exchanger, with valves for changing the flow configuration. In general, the way a double pipe heat exchanger works, it can either flow in a parallel flow configuration or a counterflow configuration. In the parallel flow configuration, the hot and cold fluids flow in the same direction, whereas in the counterflow configuration, they flow in opposite directions. Here we have a diagram of this system. You can see there are cold and hot valves, as well as 4 valves for changing the configuration of the heat exchanger, counterflow or parallel flow. And the configuration that you choose is outlined here. For parallel flow, you want to have valves 3 and 5 open and valves 4 and 6 closed. For counterflow, it's just the opposite. You want to have valves 4 and 6 open and 3 and 5 closed. And again, those valves are here. Valves 3, 4, 5, and 6. Okay. Now let's move over to the actual system and I'll show you the components. The hot and cold flow are controlled first here at the wall. You can see we have the cold water manifold and the hot water manifold, and each manifold is labeled cross flow, double pipe, heat pump. Of course, we're interested in the double pipe for both cold and hot. To turn on the system, switch the valve to the open position. Double pipe. Okay. Flows on here. So now we move back over to the system itself. Okay. And over here, you have hot and cold control valves at the system, as well as a mixing valve to control the temperature of the hot fluid. Okay, so to turn on the cold water flow rate, turn on this valve, and you can see that you have flow by simply looking at the rotometer here. Likewise, to turn on the hot flow, turn on the hot valve. And again, you can see that you have hot water flow by looking at the rotometer. There's also a handheld thermometer here, which allows you to see what the temperature is from the hot water tank. This is useful if you think you might be losing temperature for the hot water flow. Okay. Sensors for this system include 10 thermocouples. We have 2 at the hot and cold water inlets, as well as 8 at the end of each concentric pipe section. 2 here, and 4 more at the other end. Okay. There are also 2 turbine meters here, which are read via the data acquisition system here. Okay. Now, let's talk about the startup and shutdown procedures, and I will take some data. So there is a red book for this experiment. In the book, You have startup and shutdown procedures. Also a list of the channels for the data logger. There are some operation hints here that could be useful to you. And then in the back, these last pages contain uncertainties for the various instrumentation used to take data. Okay, so to start taking data, once the hot and cold water flows are engaged at the wall, simply adjust the hot flow and cold flow here, as well as adjust the hot water temperature via the mixing valve. And once you have the set points that you want, then you can head over to the computer and take some data. So we have, you just have to click the Do One Scan Now button, and there you go, numbers populate here. And you can continue doing this to take further data. So to shut down the system, simply do the same thing you did to start up the system in reverse. Turn off the cold flow rate. Turn off the hot water flow rate. And then do the same thing at the wall. So here at the manifold by the wall, simply turn off the hot water valve and turn off the cold water valve. And that's it.